Hello friends, in today's question, a U-tube of uniform cross-section is partially filled with the liquid 1. Another liquid 2, which does not mix with liquid 1, is poured into one side. It is found that the liquid levels of two sides of the tube on other side are the same, while the level of liquid 1 has risen by 2 cm on the other side. If the specific gravity of liquid 1 is 1.1, the specific gravity of liquid 2 must be. So we can solve this particular question by using two methods. In the first method, we can discuss that the pressure at the interface of the liquid, that should be same, and in the second part we can discuss or we can solve it by using that pressure at the same level will be same. Okay, both are based on the hydrostatic pressure balance. So let us first of all understand that what's the basic premise between the hydrostatic pressure balance. So we have hydrostatic pressure balance. So in particular case, you can say that at equilibrium, the pressure exerted by column in liquid 1 on the left side must be equal to the pressure exerted by the column 2 or by the column of liquid 2 on the right side. We assume that liquid 1 is on the left side and liquid 2 is on the right side. So you can say at equilibrium, the pressure exerted by the column of liquid one on left side, and this we have assumed that column 1 is already there in the liquid and the liquid 2 is poured from the right side. So the column you can say liquid 1 automatically comes to the left side. It's not a hard and fast rule, you can make it otherwise also on the opposite. Okay, so at equilibrium, the pressure exerted by the column on the liquid 1 on the left side must be equal to pressure exerted by the column of liquid 2 on the right side. So let's find out the pressure of liquid 1 on the right side, then the liquid 2 on the left side, and then we are going to equate them. So we can say from here that pressure due to liquid 1 on the left side, let us suppose is given as P1, and that will be equal to rho 1 G and H1, and pressure due to liquid 2 on the right side is, let us suppose, given as P2, and that will be equal to rho 2 G and H2. Now we also know that rather we can say it is given that they have the same level of the the liquid at the same level. So we can say that since the liquid level on the both sides is same, since the liquid level on both side is same, then the highest of the liquid 2, the highest of liquid 2 must be equal to the the height difference of liquid 1. Height difference of liquid 1. So which means basically that before liquid 2 is added, liquid 1 is present on the both sides. It's the same level at the both sides. Okay, before liquid 2 is added, liquid 1 is at same height on both sides. Okay, before liquid 2 is added, the liquid 1 will be on the left side, it will be same height, as well as the right side it will be of same height. Okay, but when liquid 2 is added, results in the rise of liquid 1 on the opposite side. Therefore we can say that 2 centimeter is the height difference of liquid 1 when liquid 2 is added. So now it's almost clear that the height difference is over 2 centimeter, and we said that if rho 1 is the density of liquid 1, so let us write it here. For liquid 1, rho 1 is its density, and SG1 is specific gravity of liquid 1, and similarly, so it is SG1 for liquid 2, rho 2 is its density, and Sg2 is its specific gravity. Therefore, we can write that rho 1 will be equal to Sg1 multiplied by the rho of water, which will be giving us 1.1 multiplied by 1000, and this gives us 1100 kg meter cube. Similarly, sorry, this is SG1, we can find out rho 2 is equal to our SG2 multiplied by water, and this gives us SG2 multiplied by 1000. SG2 we are supposed to find out. Now we are going to use the, you can say, two parts, that we assume that the hydrostatic balance at the interface in the first part, and in the second part we are going to solve same thing by using hydrostatic pressure same at the level, because when they are at same level. So we say hydrostatic balance at the interface. So it means P1 is equal to P2. We substitute the values, we get rho 1 G H1 is equal to rho 2 G S2, and this G and G cancels out. So here we get that we have already calculated, it is 1100 multiplied by H1 is equal to Hg2 multiplied by 1000 and multiplied by H2. But the value of H2 and H1 is same. H1 is equal to H2, which is our 0.02 meters, and the H2 and H2 is same because the height difference when liquid 1 is already present and liquid 2 is added is given as 2 centimeters. Okay. So this is gives us, let's write it here, this gives us that H2 is equal to our 2 centimeters because of this height difference. So therefore we can say our Hg2 will be equal to 1100 divided by 1000, and this will be giving us 1.1. The specific gravity of liquid 2 is 1.1. Now we can use the hydrostatic balance at the same horizontal level. Hydrostatic balance at same horizontal level. So it means pressure on the left will be equal to pressure on the right at the same level. Okay, so you can say pressure at left will be equal to pressure at the right. So let us draw the figure for the left as well as the right. So this is our U tube, and we already said that at the start of discussion that liquid 1 is already inside the tube, liquid 2 is poured from the right side. So let us suppose the liquid 1 is risen by 2 centimeters. So this is liquid 1 and this is given as 2, and let us suppose this height is our H. So therefore, because we said they are at the same level, so this height is our H plus 2. So this is our liquid 1 and this is our liquid 2. So pressure in the left will be because of liquid 1 as well as because of liquid 2, and pressure on the right will be only because of the liquid 2. So you can say pressure at left, which basically means liquid 1 plus liquid 2. So we get this as P left will be equal to, this density is rho 1 G and the height is 2 plus it is rho 2 G and height is H, and pressure on the right is only because of liquid 2. So we can say P right is equal to density is rho 2 G and height is H plus 2. So pressure on the left is equal to pressure on the right. We can say P left is equal to P right. Substitute value, we get rho 1 G2 plus rho 2 GH is equal to rho 2 GH plus 2. So from here G and G cancel out. So we get this as 2 rho 1 plus rho 2 is equal to rho 2 H. Sorry, here it is H, rho 2 H and plus 2 rho 2. And once again this rho 2 and rho 2 cancel out. Okay, and we get this as 2 rho 1 is equal to 2 rho 2. These also cancel out. So we get that rho 1 is equal to rho 2, and we already know that our rho 1 is our 1.1 multiplied by 1000 and rho 2 is our SG2 multiplied by 1000. So here 1000 and 1000 cancels out. So therefore we get that SG2 is equal to 1.1, sorry. Specific gravity of second liquid is 1.1. So therefore we can say that option B is the correct option. Option B is the correct one. Option B is correct. So this completes the question. Thank you.